Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to go through an exam question from 2017 paper 1, and it's question 4 part B. Now in this question we're given a square that has a sides of 2 centimeters. We're told that the midpoints of this square are joined up to form another square, and that this process is continued, okay? And they've given us the diagram for the first 3 squares. We're asked to find the sum of the perimeters of the squares if this process was to go on indefinitely. Okay, so there's a lot of information there, but first of all, you should recognize is that right, I know the perimeter of the first square straight away. Clearly each side is 2, so I know the perimeter of the first square is just 2 plus 2 plus 2 plus 2 is 8 centimeters. So I'm happy enough with that. Now clearly if this process is going to go on indefinitely, it's going to have some kind of a trend. So I'm going to need to find the perimeter of the first 3 squares so that I can identify that trend. So the first thing to do in this question is to work out what is the length of the side of one of the smaller square. And then I can do the same thing to find the length of the side of the smallest square. So you'll notice that I've marked in a few things here. First of all, they told me that these are the midpoints. So if the side of one of them is 2 centimeters, clearly the distance from the midpoint to the corner is 1 centimeter. So what I've drawn out here is I've drawn another triangle. And this triangle represents the one in the top right hand corner. I know the length of it is 1, and I know 2 of the sides of it are 1. And I know it's a right angle triangle because clearly each of the corners in a square is going to be a 90-degree angle. If I know 2 sides in a right angle triangle, I'll be able to find the third side. If I do that, that tells me the length of one of the sides of the smaller triangle, of the smaller square. So remember, your Pythagoras theorem is just that a squared plus b squared equals c squared, where c is the hypotenuse or the side opposite the right angle. So if I subtract in, I'll be able to get my hypotenuse. I can just say that 1 squared plus 1 squared is equal to c squared. So in this case, my c squared would be 2, which means c is the square root of 2. So in other words, I know that the length of one side of the middle square is the square root of 2. I know the distance from there to there. Remember, if it's a square, all the sides are the exact same. So now I just want to do the exact same thing again in order to find the length of one of the sides of the smallest square. So you'll notice out here I've drawn another triangle. And I want you to think of this triangle. For me, this is this one here. Okay, this triangle is this one here. I know that the length of the middle square is from one corner to another corner is the square root of 2. And I know that the third square is formed by joining the midpoint of each of these. If I know that the distance from here to here is the square root of 2, well then clearly the distance from the midpoint to the corner is half of that. So the distance from the corner to the midpoint is half of the square root of 2, which I'm just going to write as root 2 over 2. So in the triangle that I've shaded in here, I know 2 sides in this triangle. I know 2 of the sides in the triangle are the square root of 2 over 2. Again, clearly it's a corner of a square, so it's a right angle triangle. So I can just use Pythagoras theorem again to find the length of one side of the smallest square. So let's just substitute into the same formula. A squared plus b squared equals c squared. So in this case, it's going to be the square root of 2 over 2 to be squared plus the square root of 2 over 2 to be squared will give me c squared. So if you just plug that in, 2 squared in the bottom here is 4, and the square root of 2 to be squared is just 2. So this works out as a half plus a half is equal to c squared. So c squared is equal to 1, which means that your c in this case works out as 1. So I know that the length of one of the sides of the smaller square is 1. So now I know the length of each side of the 3 squares. This is going to allow me to work out the perimeter of each one and then work out the sum of the perimeters if this process was to go on indefinitely. Okay, so you'll notice that I've split our diagram into 3. I know that the perimeter of the first square is just 2 by 4, which is 8. The perimeter of the second square is root 2 by 4, which is 4 root 2. And the perimeter of the third square is just 4. So now I have a trend. Now I have the first 3 terms in my sequence. And I've been asked to find the sum of the perimeters of these squares if this process was to go on indefinitely. Now you should think of indefinitely as another word for infinity. So rather than getting the sum of something happening indefinitely, you want the sum to infinity. Straight away you should recognize that there's only one formula for the sum to infinity. You can get the sum to infinity of a geometric sequence. It's the very last formula in your sequence and series page in your log tables. So the minute it said get the sum if this was to happen indefinitely, you should have recognized that this must be a geometric sequence. Now we're still going to prove it's a geometric sequence in a second, but it should have come into your head straight away. The sum to infinity, or the sum of something indefinitely, it must be a geometric sequence. Because I have no way of getting the sum to infinity if it's an arithmetic sequence. So this is a relatively straightforward formula to sub into. We just need to find our A and we need to find our OR. Now A represents the first term, so in this case A is just 8. And OR is the common ratio. To get the common ratio, it's one term divided by the previous term. So in other words, it's the second term, which is 4 root 2 divided by 8, or it's the second term divided by the first term, or it's the third term divided by the second term. And you'll notice that if both of these end up as the same thing, that's us. In this line, we're proving that it's geometric. If the second term divided by the first term is the same as the third term divided by the second term, then I know the sequence is geometric. Now if I plug this straight into my calculator, for both of these you're going to get, so for this one, this is root 2 over 2, and this one is 1 over root 2. Now I've purposely done them separately like that, because I want you to recognize that root 2 over 2 and 1 over root 2 are the same thing. Root 2 over 2 is just another way of writing 1 over root 2. When we're dealing with maths, we usually use 1 over root 2. But if you plug it into your calculator, it's going to give you root 2 over 2. Because your calculator won't give you an answer where the surd is on the bottom of the fraction. But I'd always tell my students, if the answer on the calculator is root 2 over 2, write it as 1 over root 2. If you get it in decimal form, it's the same thing. It's just this is the way that we usually use it, whereas this is the way the calculator will give it to you. So now that I know my A and I know my OR, I can just sub into S infinity. So that means that S infinity is A, which is 8, over 1 minus 1 over root 2. Okay, now to finish this one off, you might be inclined to just plug this straight into your calculator. But there's actually a good bit of work involved to get to my answer from here. So I want you to pause the video. We'll start again at the top, and it's a really important few steps we have to go through now. Okay, so for this one, I just want to go through how we can algebraically get rid of our fraction here. Okay, so the problem is I have a surd on the bottom of my fraction. This is very similar to a complex numbers question. In complex numbers, when we've an I or an imaginary number on the bottom of the fraction, we multiply top and the bottom by the conjugate of the bottom. And that's exactly what we do here. In order to get rid of the surd on the bottom, I'm going to multiply 1 minus 1 over root 2 by 1 plus 1 over root 2. But I can't just randomly multiply by 1 plus 1 over root 2. If I multiply the bottom by that, I also have to multiply the top by that. Because if I multiply by the same thing on the top and the bottom, I'm actually just multiplying by 1. And I'm not changing the value of the expression. So for the moment, let's just leave the top line as it is. The top is just 8 times 1 plus 1 over root 2. And the bottom, I've double brackets that I'm going to multiply out. The first thing in the first bracket by the second bracket, 1 by 1 is 1, 1 by 1 over root 2 is just plus 1 over root 2. The second thing in the first bracket by the second bracket, minus 1 over root 2 by 1 is just minus 1 over root 2. Minus 1 over root 2 by plus 1 over root 2 is minus a half. So the reason I multiplied by the conjugate of the bottom was because I knew that this would happen. That plus 1 over root 2 and minus 1 over root 2 would cancel. And notice now I'm left with 1 minus a half on the bottom, so my surds are gone. So if we continue to simplify this, I can say that S infinity is 8 times 1 plus 1 over root 2, and the bottom of my fraction is just 1 minus a half. 1 minus a half is just a half. So now at least my surd is gone. Now you should recognize that a half goes into 8 16 times. So I can actually rewrite this. A half divided into 8, I can actually just rewrite this line as 16 times 1 plus 1 over root 2. And if I multiply this out, 16 by 1 is 16. 16 by 1 over root 2 is, so I'm just left with plus 8 root 2. Now it asked me to leave it in the form of a plus b root c, where all three of these numbers were natural numbers. Clearly 16, 8 and 2 are natural numbers, so I'm happy enough. And remember, it mentioned that that should be in centimeters, so I label it as 16 plus 8 root 2 centimeters. So I hope this video made sense. If there's anything there that you're unsure of, then just let me know in class or send me an email and I'll try and explain it differently.